Hello everyone and welcome to the Meshmixer Master Course. In this particular course module we are going to go through how to clean up a 3D scan of an inside of a test socket where we have previously spray painted that socket matte black. My name is Joe Fairley, I'm the owner of Ascent Fabrication, and let's get into it. So if we go up here to the View menu here, we're going to show the Objects browser in order to use this Object browser like a history tab. Moving the right bottom corner of the Object browser, we can move this in or out to show more of the name of whatever particular scan that we are looking at. By double clicking into the name of the scan, we can rename this as Step 1 Original Scan. And hit enter. Now if we uncheck the visibility of the eye, but the name is still checked, then we're going to be able to look through the scan itself in this pink ghosting mode. Right now I'm using the right click to rotate around the model. Right now left click doesn't do anything because I'm not using any of the tools on the left hand side. I'm scrolling in and out on my scroll bar in order to zoom in or out, and then depressing my scroll bar I can pan around the model itself. So with the original scan I checked, this was a scan that was taken of a test socket that was given to us from one of our customers, and we spray painted the inside matte black. And now you can see that I have my extraneous scan data being part of my face and my hand, which I'm going to show you how to clean up and only have the inside of that socket remaining. So step 1 is the original scan because we want to use the object browser again like a history tab. So with that, I want to, before I do anything to this scan, after I've just simply imported the scan from my file explorer, I'm going to use the 2 square button down here to actually duplicate that original scan. Sometimes, for whatever reason, Meshmixer ends up duplicating it twice. We can simply delete out that second one. Now if I uncheck the visibility of the first, in the second, I'm going to name this the clean scan. Now with that being the clean scan, what we're going to do is orient our model according to the grid, just as a plane of reference. The red dot over here also is just a main dot of reference. It doesn't really have any real value once we export that scan. So just moving around the model and orienting ourselves to the grid is going to get us into a good position for when we want to bring this model into 3D printing. So what we also could do under View is show the printer bed. Now if we show the printer bed, we can see that I'm using the Artillery Sidewinder X2 build volume as a reference. I'm actually going to use the arrow pointing forward here on the Artillery Sidewinder 2 bed reference to orient our model to that space, because when I export this for Meshmixer, it's actually going to come in that same orientation when I bring it into the slicer of my choice. So right now, again, we are in the right view, with that being kind of the front facing. If I do zoom around to the front, we're going to be oriented 90 degrees to the left. So I'll orient myself to the right hand side as my front. And in the drop down menu up top here, you can see that there's a number of different 3D printers that are already positioned within their menu bar. You can actually add your own printer by going to Printers Preferences and inputting some information about your printer, such as film innovations for the Icarus. So we just want to use this as a reference to see how big is our object, make sure that we're in the right units, and make sure that this is going to be as big as we think it's going to be when it prints. So referencing the units first, I'll go ahead and go back up to View and uncheck the Show Printer Bed. I'm going to go to Analysis and Units Dimensions. Now this is going to give me the units dimensions of the entire thing that I scanned, but you can relatively see that we're in a appropriate scale here in millimeters for what we want to achieve. So that's fine. Now let's go ahead and clean up this scan by selecting areas in the scan that we want to delete. So we'll go to Select, turn down the size of our tool, and any part of the scan that is disjointed, disconnected from another, I can simply double left click that part of the scan, go up to Edit, and Discard. Now you'll notice if I do that again, this whole piece is connected, so I don't actually want to just double click the entire piece. We'll go ahead and clear selection, go back into Select, and this time I'm going to left click and drag around the part of the scan that I want to select, and depending on the size of your selection, it could alternate to select the other side. So what we're going to do in that case is end up using the Modify tool here and click Invert, and now that inverts the selection of what we wanted. So I want to delete this out, we'll go to Edit and Discard. And now as we get a little bit closer to achieving just having the inside part of this scan be the scan data that we want, I'll go ahead and continue to delete out parts of the scan that I don't need. So we'll go to Select, select around again other parts that we don't need, and discard. And now if something is disjointed, I can select it, edit, and discard. Now I actually want to select this small area here and discard just this small area so that I can disjoin this outside part of the scan that was captured from the inside part of the scan. So to do that, we'll go to Select, I'll decrease my size of my tool, and I'll just select a piece out here, edit, and discard. And now that those are deselected and disjointed, we're still connected right over here. So we can select in that region, edit, and discard. Anywhere else we might be connected, let's see. Nope, looks like we are possibly finally disconnected. Another way to actually disjoin the scan is to go to Edit, Separate Shells. This is going to separate each individual piece of that scan so that you can simply, over here in the object browser, delete out those parts of the scan, some of which are so small that you won't even be able to see it. And so now we have the part of the scan that we actually want. You'll notice too that we have a rather large hole, but we're going to be able to clean this up relatively well just from our scan of the inside part of the socket. So now we have the scan that is not very well oriented, but we are going to orient it in this view on the right hand side, and in order to do that we go to Edit and Transform, and now I'm going to move the blue, green, and red arcs in order to rotate the model. Right now I'm positioned in local view. That means that when I rotate this, the axes are going to rotate with me. If I go into the world view, those axes stay parallel and perpendicular to the grid. Typically, I'll stick with world view. So we'll use the arcs to move the model in the direction that we want to. And as we actually end up using these arcs, you'll notice that if I stay in close to the arc itself, I can go by any amount of degrees, and you can also notice this over on the left-hand side here. If I move my cursor outward where it actually picks up the grid rotation points, I can go by increments of 5 degrees in order to rotate the model. You can also have the enable snapping tool on with a certain snap step, the actual amount that you're going to be moving this up or down. That can come into handy sometimes, say if I want to position a dummy tool in place with the scan in order to create the socket. I'm actually going to decrease that down to 1 millimeter, and then I know exactly how much I'm moving this thing around. Otherwise, you can uncheck enable snapping, which is mostly what I do in order to move the scan around freely, and just generally place it within the center of the grid that's visible. So I will align this relatively in what we would call bench alignment. Alright, now that I have my scan aligned, I can accept that. And now, because I have a gray area on the inside part of the scan, and then a red and white area here on the outside part of the scan, that means that I don't have any data on the outside part of the scan. So I want to flip the data from the inside to the outside. So I'll go ahead and select, left click, double click to get everything from the inside part of that scan. And then I'll go to Edit and Flip Normals. That is going to position all of those data points on the outside part of the scan rather than the inside. Now we still have some scan cleanup to do. As you can see, there was quite a bit of, I would say, stepping of the scan itself, where it might not have gotten a very precise aspect of the scan in those regions. So we will smooth up that scan as well as closing up this hole. There are a few different ways to close holes. The first is going to be under Analysis and using Inspector. Now these orbs, the blue, red, and sometimes there are pink orbs, show up because we either have holes, small holes, blue holes that we can actually close very easily by clicking on the blue orb. And then when there are larger holes and other data points that Meshmixer would rather us try to close in a different way, they'll be red. Now if it's not too large, I could just click on the red and then it would generally fill up that part of the scan with a nice contour. With this large of a opening in the scan, I'm going to say Done. And in this case, another way to close the scan would be to go to Sculpt. We want to be under the Surface tab, so we'll click under the Surface tab, and under Brushes, we're going to use the Robust Smooth tool. We're going to turn our strength down to 30. I can do that with the drag bar, or I can click into this number. And with the size, 30. Now I'm just going to left click, and while I'm dragging around this whole opening, the hole is actually going to start to close itself. Meshmixer does a pretty nice job of approximating that part of the scan, so you'll still get a rather good looking aspect of this hole when we're done with it that is going to follow the patient's anatomy relatively well. So once I have it a bit cleaner, I'll go back to Analysis and Inspector, and we still have a really large hole. So before I do anything to that, I'm going to hit Done. And Meshmixer sometimes likes to crash when we do big computational steps. So continuously save your work. And that's why we also, on the object browser here, have these steps numbered so that we know in what steps we performed this particular design. So we'll go back into Inspector, and I'm going to click on the red orb, and it's likely going to turn white, and I might have to wait a second for it to actually close this hole. Alright, so it closed the hole rather well. There is a rather large divot in this area, which I can approximate some of that shape of the patient's limb by looking at the other parts of the shape around it. Now, it also is going to show you this hole in the top aspect here, but we'll fill up the top later. We're not going to end up closing off the proximal end just now. So we'll hit Done. And then going back to Sculpt, under Surface again, Brushes, and this time I'm going to use Bubble Smooth. Bubble Smooth is going to, most of the time, fill in valleys, while Robust Smooth is going to take down the peaks. So I'm going to turn down the strength here to about 30 and start to smooth up this part of the scan. And if it's not performing that function relatively quickly, I could also go to Brushes and Inflate. Inflate is simply going to add material in these regions, and I can look around the model to see if I'm adding too much. So now that we have a little bit filled in order to smooth this out and make this more appearing like the contour of the patient's limb, I'm going to use the Bubble Smooth tool again with a higher strength and a little bit lower size, and I'm going to fill in some of these low spots. Looking relatively good. And I'm still going to fill this in to the point that I'm happy with it from the part of the residual limb that I know. We'll use the Brushes and Robust Smooth tool here again. Maybe about strength 50 this time. And we're going to go over the high spots of what we have just filled in. I might increase the size to go over a broader area. And we're really starting to get to more of the shape of this patient's limb. Now I don't want to push in too much, so I might go back to Bubble Smooth. And the more you hold down the cursor, the more it's actually going to increase that part of the scan. So I think we've just about put as much material as we really want there now. We're going to go back to Robust Smooth. And make sure that contour looks relatively good. Alright, now that we have cleaned up this portion of the scan, we can go and clean up really all of the more pixelated aspects of this scan. We're going to decrease the strength down to 30. Increase the size, and this is going to help smooth up that pixelation while not reducing the model very much at all. The more you smooth up the scan, the more you are actually taking off material and then reducing the volume of the scan itself. Now, if I believe that there is a small divot here that really shouldn't be there, we'll go back to bubble smooth again, decrease the size and strength, and if that was too much, we can just hit Control Z and undo, decrease the strength even more, and fill in that small void, and then go back over it with robust smooth with maybe a little bit bigger size, a little bit bigger strength. And make sure that that is contoured well. As well as the distal end. Go back to bubble smooth to fill in what I know to be small holes just based off of taking a look at the test socket itself. And then we'll go back to robust smooth. Alright, now as we get up to the proximal edge, you'll notice that when I use robust smooth, I can go up to strength 45, size back down to about 30, and as we go around it, the jagged edge is going to become more smooth. You'll notice that any areas of convexity are going to be dropped down, any areas of concavity are going to be pulled upward. It will also reduce parts of the scan that would otherwise be an artifact. In this region where I know it's not going to smooth anymore and I need to get rid of that little pinprick up here, I'm going to use the select tool and decrease the size, select that region. If I hold down Control and left click, it will allow me to deselect some part of the scan. And I'm going to go to Edit and Erase and Fill. That is going to get rid of that jagged edge for me and give me a good approximation and smoothness of that part of the scan. We'll accept. And now going back to Sculpt, Brushes, Robust Smooth. We'll bring the strength down to about 30, size 30. And now you can see how we've smoothed up that part of the trim line. I'm going to go all the way around the trim lines until they're nice and smooth. Again, without trying to alter what I know to be the general shape of the trim lines and socket itself. And there you have it, a fairly smooth scan all the way around. I'm going to go ahead and file save because I've kind of completed a major step in my design. And now, in order to change this from an open-ended scan, because this is only the surface level scan data, this is not a solid scan, I want to close off the top and make it solid. I do see here a part of the scan that's actually concerning me a little because of the jagged triangular shapes of the grayed areas here. It doesn't look like the nice smooth areas adjacent to it. So I'm going to use the select tool again, turn down the size, just select this small area and edit, erase and fill, accept, back to sculpt, brushes, robust, smooth. And now that area is not going to give us any issues when we go to create a solid shape. So, saving, I'm going to go to the select tool now, and I'm going to bring my cursor directly next to the blue line and double click the blue line. If I hold down Control and go forward on my scroll bar, I can increase my selection, and backward on my scroll bar, and I can decrease my selection. You just want to make sure that you have a selection all the way around where you don't have any part of the scan missing there. Next we'll go to Modify and Smooth Boundary. And in Smooth Boundary, we're going to turn the smoothness all the way up. And as we do that, you'll notice that the line all the way around does get rather smooth from that jagged shape that was selected. And we can also increase the iterations. Once we increase the iterations, that will actually kind of pull down and decrease the height of the trim lines overall. So you don't want to increase the iterations too much to where you're affecting that shape of the scan. We'll go ahead and hit accept. Now with that, I want to deform and transform. And as I transform this part of the scan, I want to be in world view. And I'm going to use the green arrow to pull this part of the scan upward. And I want this part of the scan to be so far up that when I do a plane cut right above the trim lines, I'm going to end up with a nice flat top where I still can see the trim lines. So we'll accept that. And now this new part of the scan is actually going to have some pretty jagged edges to it. So I'm going to double click that part of the scan as well. I'm going to go to Deform and Smooth. I'm going to turn the constraint rings down all the way and turn the smoothing scale up about halfway. And now we have a nice smooth part of that scan. We're going to hit accept. And then, in order to view where those trim lines are at, I want to edit and extrude this proximal edge 3 millimeters, hardening 100 in a normal direction. And in doing so, we can notice that we can see the indent of the trim lines all the way around the socket. We'll accept that. Sometimes it's best to just let Meshmixer wait and finish the computation. And as that's done, we can file save. Going into Sculpt now one more time. And under Surface, Brushes, Robust, Smooth, strength about 30, size about 30. We're going to go all the way around the trim lines now. And we're starting to lag a little bit. So we'll just wait for Meshmixer to respond. We're actually lagging quite a bit, unfortunately. So I'm just going to go through this, smoothing rather slowly. Any jagged edges, I want to make sure that they're smoothed, but we're going to want to go around the trim lines all the way because we're essentially stitching together these two new parts of the scan that we've just created. Meshmixer isn't always this slow. As I'm doing the recording here, it's bogging down my computer a little. And now for some reason it has stops being so slow. And in this corner here you'll notice that part of the scan has actually caved in on itself. I'm going to chase this upward and you'll notice these black sparkles here. If we chase this upwards we know that we're actually closing that part of the scan, which is what we're looking for. So now that we've gone all the way around, and now this is actually quite faster. This is the speed that it should be. I'll go back around one more time. And maybe it's this posterior section that's really giving us the trouble. Alright, now that we have that done, we're going to go to Edit, Plane Cut. We're always going to be in the local view for plane cut. I'm going to switch what I'm cutting and click on the big blue arrow, and then pull the little blue arrow upward so that I have a completely closed off top. If I move this upward too far, then you'll notice that I still am not cutting in a parallel direction where I have an entire part of the scan. So I want to pull that more distal until it's actually showing it closed. Right now that's under remeshed fill. If I ended up saying no fill, it would still leave it completely open. For this we're going to do remeshed fill and then hit accept. And so there you have it. We now have a clean scan of a positive limb shape that was taken from the original scan here of the inside of a test socket that was scanned with comb, and the socket was painted a matte black. If we want to see the color version of this, we can go to File and Preferences, and under Mesh Color Mode choose Vertex Color instead of Group Color and hit Done. And now we can see the actual color in this scan. And you can see the color in my shirt. We can find the color in this only because this scan is an OBJ file. If the scan was an STL file, then if we clicked into Vertex Color, all we would end up seeing is still the grayness of the scan itself. One last thing I'll show you on this video here. For the clean scan, if I end up going to Edit and Generate Face Groups, face groups are actually just color representations of the different parts of the scan. If I turn down the angle threshold, you can start to see that we have thousands and thousands of triangles that are making up this scan. And as I increase the angle threshold up to about the R in threshold typically, we're actually making Meshmixer think that all of this part of the scan that is not the plain cutted proximal end is one face group that we can then left click, double click to select, and that does come in handy later down the line. You might find that with some of these you'll have very, very small triangles that you otherwise couldn't see. So if you continue to turn up the angle threshold, then you'll be able to capture some of those triangles. But we just don't want to go so far that there's one whole face group on the entire model. We do want the proximal end to be a different color, and that will be apparent later on in the Meshmixer Master Course series. Thank you everyone for watching this particular video. Tune in for the other Meshmixer Master Course videos for more training on how to use Meshmixer to create prosthetic devices and orthotic devices. Thank you.